Module 9.3, using the quadratic formula to solve equations. Essential question: what is the quadratic formula and how can we use it to solve quadratic equation? Well, the quadratic formula or the form for the equation ax squared plus bx plus c equal to 0. To solve for x, the formula is x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, and I'm going to skip the deriving the quadratic formula. I'm just going to give you guys the formula. Right? So this is the formula for the quadratic equation. So x equal to negative b plus or minus square root of b squared minus 4ac all over 2a, and the expression b squared minus 4ac is called the discriminant, and this will let us determine the number of solutions for our equation. So we see that if b squared minus 4ac is greater than 0, then we have two real solutions. Okay, and then if b squared minus 4ac is less than 0, then we say that we have no real solution. And if b squared minus 4ac equal to 0, then we say that we have one real solutions. Alright? Okay. So then we say that we have this formula here is called your quadratic formula, right? So okay, so once again, this is the quadratic formula. Say that x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Right, so then let's go to our first example. I said use the discriminant to determine the number of real solutions. Recall that a quadratic formula equation ax squared plus bx plus c can have two, one, or no real solution. By evaluating the part of the quadratic formula under the radical, b squared minus 4ac is called the discriminant. You can determine the number of real solutions. Right, so once again, if we have b squared minus 4ac greater than 0, then we have two solutions. If we have b squared minus 4ac, if it's less than 0, then we have no real solution. And if b squared minus 4ac equal to 0, then we have one real solutions. Okay, so let's say, for example, determine how many real solutions each quadratic equation has. Right, so from here we know that the value of a is 1, the value of b is a negative 4, and the value of c is a 3. So then we're using the discriminant b squared minus 4ac. So we have a parenthesis negative 4 squared minus 4 times a, which is 1, and times c, which is a 3. So then we have a 16 minus the 12. So the answer is 4, which is greater than 0. That means that we have two real solutions. Right, let's go on to our next example. So example B, we have a x squared minus 2x plus 2 equal to 0. So once again, identify the value for a, which is negative 1, b equal to 2, and c equal to 2. And the discriminant is b squared minus 4ac. So we're going to do 2 squared minus 4 times negative 1 times a 2. So this gives us 4. Negative 4 times negative 1 is positive 4 times 2, which is positive 8. So equal to 12, which is greater than 0. So once again, we have two real solutions. Okay. Go on to our discussion. So when the discriminant is positive, the quadratic equation has two real solutions. When the discriminant is negative, there is no real solutions. How many real solutions does the quadratic equation have if its discriminant equal to 0? Right? So if we say that if b squared minus 4ac equal to 0, then we have one real solutions. Right? Because if we have a negative b plus or minus square root of 0 over 2a, then the answer will be just negative b over 2a. So then we only have one solution, there's no plus or minus. Okay, so now it's your turn. Use the discriminant to determine the number of real solutions for each quadratic equation. Okay, so for number 3, since the number is 12, which is greater than 0, so we have two real solutions. Number 4, the answer is negative 104, which is less than 0, so we have no real solutions. Number 5, 36 minus 36, which is a 0, and that means that we have one real solutions. Right, so now we're going to use the quadratic formula to solve our quadratic equation. Okay, so example 2, we have the equation 2x squared plus 3x minus 5 equal to 0. Right, so we have identified that our a is 2, b is 3, and c is a negative 5. So we're going to solve for x equal to negative 3 plus or minus square root of 3 squared minus 4 times 2 times a negative 5. Make sure that you carry the negative with you. And 2 times 2. So this gives us a negative 3 plus or minus 3 squared, which is 9, and negative 4 times 2 is negative 8. Negative 8 times 5, which is the positive 40, over 2 times 2 is 4. So this gives us negative 3 plus or minus square root of 49 over 4. But square root of 49 can be reduced. So negative 3 plus or minus 7 over 4. Remember that plus or minus, that means that there are two answers, so we're going to break this up. So x equal to negative 3 plus a 7 over 4, or x equal to negative 3 minus 7 over 4. Right, so 4 over 4 reduced to 1, or negative 10 over 4 reduced to negative 5 over 2. So we have two answers. Okay, let's go on to our next example. So here we can solve our equation by graphing, right? So we can see that the x-intercept, which is x equal to 1, or on this side we have a negative x-intercept, which is negative 2.5. Okay, so example B, we have a 2x equal to x squared minus 4. So to solve for this, remember that one side of the equation must be 0, so it's easier if we minus 2x from both sides. So we have 0 equal to x squared minus 4x, oops, my mistake, minus 2x minus 4. So our A is a 1, B is negative 2, and C is a negative 4. Right, so we see that the formula x equal to negative b plus or minus square root b squared minus 4ac all over 2a. So negative 2 plus or minus square root of negative 2 squared minus 4 times 1 times a negative 4 all over 2 times 1. Right? So negative 2 gives us a positive 2 plus or minus negative 2 squared is 4. 4 times negative 4 is a positive 16, all divided by 2. So this gives us 2 plus or minus square root of 20 over 2. So this gives us x equal to 2. Square root of 20 can be reduced to square root of 4 times square root of 5 over 2. Equal to 2. Square root of 4 is 2 radical 5 over 2, which can send these are all 2, so they all reduce. So be 1 plus or minus square root of 5 over 1, or just 1 plus or minus radical 5. Right? Okay, let's go on to the next example. Right, so then for number 6, it's saying that discussion, how can you use substitution to check your solution? Right? So substitute each value into the given quadratic equation to see if it leads to a true equality. Okay, so now it's your turn to solve for the quadratic equation using the formula. So once again, the formula is x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Right, so for number 7, the answer is x equal to 7 or negative 1. Right, so I need more rooms to work out number 8, so I'm going to clean out this part. Okay. So for number 8, the a value is 2. Before we do that, let's set the equation equal to 0 by minus ax plus 7 plus a 7. So that's reduced to 0. So we have 2x squared minus ax plus a 7 equal to 0. So now our a is going to be 2. So 64 plus 56 is square root 120. Square root 120 can be rewritten as, let's see, 4, 30, 5, and 6. So this can be written as 8 plus or minus square root of 4 times square root of 30 over 4, which can be written as 8 plus or minus 2 square root of 30 over 4. Reduce everything by 2, so we have a 4 plus or minus square root of 30 over 2. Right, so that's the answer to number 8. Okay, so then this will be an example for day 2. Right? So for day 2, we're still using this formula here for the height of an object. So we have a negative 4.9 t squared plus vt plus s. Now, some of you say that on module 9.2, we're using the equation h equal to negative 16 t squared plus vt plus s. Now, when we use this equation, that means that we're measuring in terms of feet. When we're using this equation, we're using the we're using the metric, right? So then we use this in terms of meter, centimeter, and kilometers. Okay, so then be careful with the two equations, right? So they are the same equation, but one is using the American measurement in terms of feet. The other one, negative 4.9 t squared plus vt plus s, is using the international standard metric system. Right. So let's go to our first example 3. Right. So that a diver jumps from a platform 10 meters above the surface of the water. The diver height is given by the equation h equal to negative 4.9 t squared plus 3.5 t plus 10, where t is the time in seconds after the diver jumps. For what time t is the diver height is 1 meter. So then we're using 1 meter. So then our equation is going to be 1 equal to negative 4.9 t squared plus 3.5 t plus 10. So then we're going to subtract 1 from both sides. So we have 0 equal to negative 4.9 t squared plus 3.5 t plus 9. So then our a value is going to be a negative 4.9, and b is 3.5, and c equal to 9. So then we're going to use the quadratic equation to solve for this. So we say that t equal to negative 3.5 plus or minus square root of 3.5 squared minus 4 times negative 4.9 times 9 all over 2 times negative 4.9. Right, so from this on, we need to use our calculator. Right, so negative 3.5 plus or minus. I'm going to use all of this using the calculator. Okay, so just give us 13.745 over 2 times 4.9, which is a negative 9.8. So we see that t could be equal to negative 3.5 plus 13.745 over negative 9.8. Right, so this gives us the answer of a negative 1.05 second. Remember, since t is time, so it cannot be a negative, so we cannot choose this answer. So then the other answer would be negative 3.5 minus 13.745 over a negative 9.8. So then this gives us t equal to 1.76 seconds. So we would choose these answers. Okay. Right, so this is another example. So let me fix this. Right, so instead of the height in meters of a model rocket on a particular launch can be modeled by the equation h equal to negative 4.9 t squared plus 102t plus 100, where t is the time in seconds after its engine burns out 100 meters above the ground. When will the rocket reach a height of 600 meters? So that means that you must set this up as 600 equal to negative 4.9 t squared plus 102t plus 100. So subtract 600 from both sides. So we're going to have a 0 equal to negative 4.9 t squared plus 102t minus 500. So then from here we can solve all of this using our calculator. Negative 102 plus or minus square root of 102 squared minus 4 times negative 4.9 times a negative 500, all divided by 2 times negative 4.9. So this gives us 24.57 over negative 9.8. So t equal to negative 102 plus 24.57 divided by a negative 9.8. So then one answer, we have a negative 102 plus 24.57 over negative 9.8 with an answer of 7.9 seconds, or t equal to negative 102 minus 24.57 over negative 9.8. 2 minus 24.57 divided by negative 9.8. So then we have t equal to 12.9 seconds. Right? Okay, so here is, so then we have 2 times for t at 7.9 seconds and 12.9 seconds. Okay, which means that we're getting the time for the rocket at 7.9 seconds. The rocket is on its way up, and at 12.9 seconds the rocket is on its way down. So then both of this distance is 600 meters above ground. Okay. All right. So let's see. Right. Okay. So whenever you guys try this one out on your own, say that a soccer player uses her head to hit the ball up in the air from the height of 2 meters with an initial velocity of 5 meters per second. The h height in meters of the ball is given by the equation h equal to negative 4.9 t squared plus 5t plus 2, where t is the time elapsed in second. How long will it take the ball to hit the ground if no other player touches? So hit the ground, that means that our final height is going to be 0. T squared plus 5t plus 2, so surface we set t equal to negative 5 plus or minus square root of negative 4 point, oops, wrong one, 5 squared minus 4 times negative 4.9 times 2 or over 2 times negative 4.9. So let's use our calculator to calculate the discriminant. So 25 so this gives us 8.01 over negative 9.8. So then our time would be negative 5 plus, I'm going to round up to 8 over negative 9.8. So this gives us a negative 3.036 seconds. Since time is positive, cannot be a negative, so we're going to cross that out. The other time will be t equal to negative 5 minus 8 over negative 9.8. So then t is going to be at 1.33 seconds. Okay, so this, remember that your time must be a positive. Okay, and this is another equation. So you see that a quarterback on a football team throw a pass to a team's receiver. The height h in meter of the football can be modeled by the equation h equal to negative 4.9 t squared plus 3t plus 1.75, where t is the time elapsed in second. The receiver catches the ball at the height of 0.25 meters. How long does the ball remain in the air until it is caught by the receiver? So that means that our height is going to be 0.25 equal to negative 4.9 t squared plus 3t plus 1.75. So we're going to subtract 0.25 from both sides of the equation. So 0 equal to negative 4.9 t squared plus 3t plus, so it's going to be 1.5. Right, so to solve for t, we say that t equal to negative 3 plus or minus square root of 3 squared minus 4 times negative 4.9 times 1.5 or over 2 times negative 4.9. Okay, and then use the calculator to solve the discriminant under the square root. Okay, so this, I'm going to round this up to 6.2 over a negative 9.8. So then our t be negative 3 plus 6.2 over negative 9.8. So this is going to be a negative numbers, right? So then we don't need that. So we need a positive, so we need negative 3 minus 6.2 over a negative 9.8. Right? Okay, so then our t is going to be at 0.94 seconds. Right. Okay, so that's the end of our notes, right? So these are the three questions that I need you guys to consider. How can the discriminant of a quadratic equation be used to determine if the number of zero or x-intercept that the graph of the equation will have? So we see that if the discriminant is a positive number, then we have two real solutions. If the discriminant is a negative number, then we have no real solution. If the discriminant is a zero, then we have one real solution. Right, for number 12, what advantages does using the quadratic formula have over other methods of solving quadratic equations? So one advantage is that the quadratic equation will solve for all quadratic equations. Plus, the other method is that sometimes we cannot factor. Right? And then for number 13, essential question. How can you derive the quadratic formula? So we derive the quadratic formula by completing the square. Okay, so now this is the summary of our equation. Right? The number of real solution for ax squared plus bx plus c equals 0. So when the discriminant is greater than 0, we have two real solutions. When the discriminant is less than 0, then we have no real solution. When the discriminant is 0, then we have one real solutions.